Okay, this is Calculus Integrals, Part 2, day number 6 on trig substitution. We're going to eat cookies today. It's good. Gabriel's horn investigation, don't worry about that. We're going to jump straight into this. Okay, so what do you notice about trig substitution? We're going to substitute in a trig function. Ooh, yucky. Because as I look at this integral, right, this does not look pleasant. Seeing that I can't use u sub. I can't do integration by parts. If I tried to, it'd be really ugly, right? It kind of looks like an arc sine, right? X squared, the square root of x squared minus something. Kind of looks like that, but it's flipped over, and normally we see the square root in the denominator. It's just ugly. So we're going to use what's called trig substitution. Okay, so in this case, on the test, I will tell you use x equals 3 secant theta. You'll be given that. You won't be given dx. You'll have to calculate that yourself. So in this case, you need to know that the derivative of 3 secant theta is 3 secant theta tangent theta. And that, I think, is laid out in this packet. You got some help there. Okay, so far, so good? All right, now let's do the work. Okay, so I'm going to plug in 3 secant theta everywhere I see an x. All right, some identities will show up here. So I've got 3 secant theta quantity squared minus 9 over 3 secant theta. And then when I replace dx, that's going to be replaced with 3 secant theta tangent theta d theta. Oh, yuck. Gross. It looks worse, but it's actually going to get nice. Okay, what do you see right away that you can just get rid of? Not the squared yet. I see this 3 secant here and this 3 secant here, and they go, chow, see ya. Okay, so let's simplify, and then we'll start to see some things changing. Okay, so if I square 3 secant theta, I get 9 secant squared theta. So I get the square root of 9 secant squared theta minus 9. You should see something there that you might want to factor out in a moment, right? So I can't take the square root of the sum of two items. Right? I have to have one term inside. So what I'm going to do in a moment here is I'm going to factor out this 9, and if I take the square root of that, that's 3. So I've got 3 times the integral of square root of secant squared theta minus 1. Ooh, identity. Identity. I factored a 9 out of both the secant squared and the negative 9. Comes out as a 3. Does anybody see the identity? Do you remember which one it is? It's tangent squared, right? So I have here with me, yes, it's unbelievable, 3 times the integral of the square root of tangent squared theta times tangent theta d theta. Oof. What's the square root of tangent squared? Tangent. Oh, nice. So if the square root of tangent squared is tangents, I really just have tangent times tangents, which is tangent squared. Okay. Now, the next step, you're going to say, well, why did you do what you just did? I'll show you in a second. All right, so I have 3 times the integral of tangent squared theta, d theta. Well, what's the integral of tangent squared? I don't know either. But I do know the integral of secant squared, do you? Tangent gives me secant squared. So I'm going to use the identity I just used and call tangent squared. Oops. Why is this all goofy? I'm going to call it secant squared theta minus 1. So I use the same identity I did earlier now to help me to integrate this, because I can't integrate tan squared theta. The integral would be 3 times tan theta minus theta plus c. Okay, plus c. Now we do have some work though, because what was the variable in the original portion of the problem? It was x. It wasn't theta, it was x. So we've got a little bit of work to do to get it back to where we were. So let me pause this so I can get some more space. Okay, so how can I figure out what theta equals? All right, I want to know what theta equals over here so that I can write this integral in terms of x. The arc secant. So that's an ugly one to mess with, right? But what would you do, Diogo? That. Okay, so first let's move the 3. How would you move the 3? Divide. So I'd get x over 3 equals secant of theta. I like working with cosine a lot more than secant. So I can flip this over since they're reciprocals. Okay, so then how can I isolate cosine? Or excuse me, theta? Arc cosine. So theta equals the arc cosine of 3 over x. Okay, we got theta. Theta is arc cosine of 3 over x. Now let's plug it back in. So the integral. Oh, yeah. This is really good. The tangent of theta, theta being the arc cosine of 3 over x minus 3 times the arc cosine of 3 over x plus c. Unfortunately, we're not done yet. Okay, here's why. My firstborn child is faster than I am, so I couldn't catch them. I'd have to go for the weak one, the 2-year-old. And he's scary, so I don't know. I think I'm out of luck. Okay? That is fully reduced. Okay? That is fully reduced. The arc cosine of 3 over x. I can't go any further. But I can go further with this. You do. So I'm going to draw a triangle. Watch me draw a triangle. Draw a triangle. Right? Do. So the arc cosine of 3 over x means that the cosine is 3 over x. But I want the tangent of that angle, right? I want the tangent of that angle. So I need this opposite side over here, which would be using Pythagorean theorem. Hold on, let me check my tattoo. Yep. Still that. X squared minus 9. Oh, wait, didn't that show up in the original part of the problem? Oh, filth. Straight filth. Straight filth. It is. Actually, we made up this language and it works out, and then everybody thinks we're smart. Okay, so what is 3 times the tangent of this angle? Well, the tangent would be opposite over adjacent. So the 3's will cancel, which is very nice. You're welcome. Minus 3 arc cosine of 3 over x plus c. Those 3's, they go bye-bye. I get the square root of x squared minus 9 minus 3 arc cosine of 3 over x plus c. Now we're done. Okay, let's talk some logistics of how you'll be graded on this, okay? Let's talk logistics. Oh my gosh, how did I do that? It's still recording. There we go. Okay, those of you on the World Wide Web, that's all I got for you, but I'm going to talk to the rest of these children about eating cookies and how I'm going to grade this. Here is the cookie problem, and what we want to do is take this cookie that's painted, ooh, that'd be gross, frosted, half white, half brown, or half chocolate, half vanilla, and we want to find how we can cut this cookie vertically along this line, perpendicular to where the colors change, so that each of the 4 people that get part of the cookie get the same area of chocolate and vanilla. Oof. So wouldn't it be nice if it was a square cookie? Yeah, that'd be great, but it's not. Cut it perpendicular. Oh, that'd be nice. But let's talk theoretically where this should be. It should make sense based on the curve of the cookie. Let's just go to the first quadrant, right? Based on the curve of the cookie, that we wouldn't want to cut it in half, because it's going to be, we'll come up short on the right side as opposed to the left. So it's going to be somewhere to the left of 0.5. Let's just assume this cookie has a radius of 1 foot. That'd be awesome, right? Could we find the total area of that quarter of the cookie? Yeah, it'd just be pi r squared divided by 4, which the radius is 1, so this whole area should be pi over 4. So how much of the, let's say we're on the chocolate half, how much would we have here, and how much would we have here? Pi over 8. So I want an area of pi over 8, but I need to know what this function is. Well, this is a circle, and therefore the function we will be integrating is the square root of 1 minus x squared. So we're going to plug in for x sine theta. Sine theta. And we're going to do some trig substitution. Luca.